All right, welcome back to physics. What we're going to be working on today is a little simulation that's been set up by the University of Colorado. It's called a Phet, P-H-E-T simulation. And what this does is lets us model constant velocity, in other words, an object moving at the same speed. And then more important to us, it lets us model and evaluate what happens to an object when it is increasing or decreasing in its speed. And so because we're going to need that information when we go to create our model. So without delay, let's take a look at what we've got. So we're back at our main home page and texting while driving. All right. So past systems analysis and on down to a simulation of constant acceleration. Okay. And so what I want you to do is go into this assignment. And this assignment is going to be a Google Doc. And it's called The Moving Man. So when you go into this Google Doc, there is really very, very detailed instructions about how to use this simulation. And here's the web address for it, phet.colorado.edu. This is what you're looking for. There are three ways to get into that, either as a Java or as a browser or just playing it embedded. And so sometimes some of those work better or worse, depending on your computer and your internet. So first thing, get in and play. How do you move the guy around? What are these little buttons and things for? How do they work? Once you're going, okay, I get this, then reset all the values and start going through these questions. So on our first day of playing with this simulation, I want you to go in and fill out this table. Now, when you get to the graphs, this data page was set up for us to do this in-person brick and mortar, which we're not doing. So if you want to, though, you could print this Google Doc and then manually plot the data, okay, for position and velocity, and then rescan this into your computer to submit to me. That's kind of the long way around the barn. Second way you could do it is you could take the data in the data table, evaluate it in Desmos, create your graph, and then do a screenshot and paste it in into this area. All right. The third way, which I think is the easiest way, is once you've created the graphs in the simulation, just do a screenshot and paste them in directly. Okay, that's the fastest, easiest way. All right. I'm expecting during the first day that you're only going to get through question 7, which is all about constant velocity. On the second day, where we went is to do the second half of this and work with the same simulation, the same Phet analysis, and do this part on constant acceleration. So you're still going to have a new data table. You're going to have a new graph, okay, which you can cut and paste in again. Okay, that looks like that, velocity and position. And answer some questions about that whole thing. When you have this whole thing done, put it into your eBinder, okay? Put it in your eBinder, submit it to me. All right. The second thing that I need you to be working on is a little second mini lab. And this time the mini lab, because we need information on your response time, your distraction reaction time. So part 6, all right, so you're going to skip part 5, don't do part 5. Do a simulation of constant acceleration, skip over to part 6, distraction reaction. Okay, when you get to distraction reaction, you're going to see some Google slides. And the Google slides, go into test for distraction reaction. And within those Google Slides, okay, you are going to find slide number 3, which has some resources on it, and do all of them, okay? But I'm just going to show you one as an example. What we're interested in is your reaction time. So in this particular one, you're going to start, and it's like the car is driving down the road, a stop sign is going to happen. And when it comes up, then you just hit your button as quick as you can. And I was like really slow. So you could try again. I'll do it one more time. And what we're interested in is how fast you can click that button. So yeah, I was way old. Okay. So hopefully you're going to do that a lot better. And what I need you to do is come back to class with that number so that we can put it into our model next time.